This titration lab was conducted to find the molarity of the unknown HCl. These are the materials used for this titration. This electronic pH meter with electrode and pH 4 buffer will be used to find the pH of the endpoint. These are the pH 7 buffer, 0.1 molar NaOH, unknown HCl, and distilled water used in the titration. These are the beakers and funnel that will be used during the titration. This is the burette that will add base to the unknown acid throughout the titration.
This is the stir plate and stir bar that will help mix the base and acid that will help with getting an accurate reading and keep it constantly mixing.
The titration was begun with preparing the pH meter for use. A pH 7 buffer was poured into the small beaker to calculate the pH meter. The pH meter was put into the pH 7 buffer while already including the pH 4 buffer. The pH meter then began calibration. The pH meter calibrated to pH 7.01 and soon reached 7.00. The pH meter was then calibrated. After calibration, the pH meter was cleaned with distilled water for future use.
A pipette filler was then prepared.
The pipette was put into the unknown HCl. The pipette clearly indicated the 25 milliliter mark. 25 milliliters of unknown HCl were needed. The pipette filler was used to suction the unknown HCl to exactly 25 milliliters. The 25 milliliters of unknown HCl were then added to the large beaker. 75 milliliters of water was added to the unknown HCl to dilute it. 5 milliliters of NaOH were put into the burette. The burette was rinsed twice with the 5 milliliters of NaOH.
The burette was then filled to a little bit above 0 milliliters. A small volume was released to eliminate air bubbles. The NaOH was then exactly level at 0 milliliters.
The stir bar was then added to the 25 milliliters of HCl and 75 milliliters of diluted water mixture. The electrode was then immersed in the HCl solution. The stirring bar was then turned on to spin at a slow rate. 1 milliliter of NaOH was then added to the HCl solution. The pH of the first milliliter added calculated to a pH of 1.69. 1 milliliter of NaOH was added at a time throughout the titration while recording each pH result. At 26 milliliters of NaOH added, the pH of the solution jumped, going from a pH of 2.80 to a pH of 10.48.
At 45 milliliters of NaOH added to the solution, the pH finally reached 12.
Every milliliter and the pH of every milliliter added were recorded for later data usage. After completion of the titration, cleanup began. Distilled water was used to clean the electrode. Kim wipes were used to blot the electrode dry. Average wipes could damage the electrode. The electrode was returned to the pH 4 buffer. A stir bar retriever was used to remove the stir bar from the beaker.
All beakers were cleaned using a large amount of water and then dried with paper towels.
The data was graphed to create a titration curve. The curve was used to find the volume of NaOH needed to reach the endpoint. The stoichiometry was used to find the molarity of the unknown HCl. A chemical formula was written and balanced. The molarity of the unknown HCl was found to be 0.064 moles over liters. A percent error was then calculated. The percent error came to be 36.0%. The purpose of this lab was to use titration to find the molarity of an unknown HCl and the percent error.